Hello dear students, welcome back to my video lecture 6 on hydrogen and its compounds. In the previous video we finished one of the important compounds of hydrogen, that is hydrides. Now in this video I will take up the next compound of hydrogen, that is water. We will talk about water. We know its composition, it is H2O, isn't it? Water, H2O. Is this correct? Now we know this compound of hydrogen is one of the most essential component. It is one of the most essential compound for all the living systems, isn't it? Either for human beings or for animal kingdom or for plants. For any living systems, water becomes one of the most important compound for its survival, isn't it? See, if I take an animal body, an animal body is comprised of 65% of water, including us. Our body, the entire body is composed of 65% of water. And if I take a plant body, it is composed of 95% of water. The entire plant will be composed of water. 95% it is composed of water. And if I take the earth crust, the 75% of the earth crust is filled with what? Water. 75% of the earth crust is filled with water, isn't it? Yes, without water it becomes very difficult for any living system to survive. So now in this video we will talk about the physical properties of water, and very importantly we will talk about the structures of water, the different structures of water in different states. That means we will talk about the structure of water in gaseous state, that is in vapor state, and in solid state. That means I'll be talking about the structure of ice. I'll be talking about what? The structure of ice. So before that, let us speak something regarding the physical properties of water. What are the different physical properties of water? Observe. Yes, physical properties of water. Physical properties of water. See, we know, yes, it is a colorless, yes, tasteless and odorless liquid, isn't it? At room temperature water exists in liquid state, correct? At room temperature water exists in which state? Liquid state. And all these things you know this very well. It's a colorless, tasteless and odorless. We don't require all these things. What we require is concentrate and focus on this point, what I'm telling you now. In solid state or in liquid state, in solid state or in liquid state, that is in condensed state, isn't it? Solid and liquid state are the condensed states of water. In solid state and in liquid state, that is in condensed state, water shows some unusual properties. It shows some unusual properties. Observe here, look at this. Yes, in solid or in liquid state, that is in the condensed state, water shows some unusual properties. What are those unusual properties? See, we know liquid water has high melting point, than hydrogen sulfide, isn't it? Water has high melting point than hydrogen sulfide. Moreover, as I said, at room temperature, water exists in liquid state, whereas hydrogen sulfide exists in gaseous state. At room temperature, water exists in liquid state, hydrogen sulfide exists in which state? Gaseous state. It's a gas. And also the melting point of water is more than that of hydrogen sulfide. Why melting point of water is more than that of hydrogen sulfide? Because the water molecules will be associated through which bond? Yeah, the water molecules will be associated through hydrogen bond, like this. The water molecules will be associated through what? Hydrogen bond. Since the water molecules are associated through strong hydrogen bond, okay, the melting point of water will be very high. If I consider hydrogen sulfide, H2S, okay, there is no hydrogen bond. There is no hydrogen bond between hydrogen sulfide molecules. Therefore, hydrogen sulfide molecules are free. They are free. That is why hydrogen sulfide, okay, they exist in gaseous state. Whereas water molecules are held together by hydrogen bond. They are not free. That is why water exists as liquid at room temperature. Since there is a strong force of attraction between the water molecules, it has high melting point when compared to hydrogen sulfide. That is what I am telling you. Okay, in condensed state, okay, water shows some unusual properties. Not just this property, it also has so many unusual properties. What are those some unusual properties? Okay, yes, look at here. If I talk about the dipole moment of water molecule, okay, yes, if I talk about the dipole moment of water molecule, yes, water has highest dipole moment. It has highest dipole moment. That is why water is a best polar solvent. Water is a best polar solvent. Are you getting my point? Okay, see, observe the molecule of water, OH. Okay, yes, we know oxygen is more electronegative than hydrogen. Therefore, oxygen will get partial negative. Okay, hydrogen will get partial positive. Here also oxygen is more electronegative than hydrogen. Oxygen gets partial negative, hydrogen gets partial positive. The dipole moment is towards oxygen. The dipole moment is towards oxygen, and the net dipole moment will be in the upward direction. Okay, yes, the angular dipole moments will not cancel. Okay, the net dipole moment will be in the upward direction. The actual dipole moment of water molecule is about 1.84 dBi, a very high dipole moment. Hence, water is a best polar solvent. It's a best polar solvent. Okay, and also water has high thermal conductivity. High thermal conductivity, correct? It's a very good conductor of heat and electricity. It is a very good conductor of heat and electricity. Not just this, okay, water has high enthalpy of fusion. Understand this. What do you mean by enthalpy of fusion? Okay, it has high enthalpy of fusion. What do you mean by enthalpy of fusion? I have discussed this in thermodynamics. Okay, what is enthalpy of fusion? Okay, if solid state gets converted into liquid state, what is it called as? If solid state gets converted into liquid state, okay, what is this called as? Yeah, this is called as enthalpy of fusion. If liquid state gets converted to gaseous state, this is also called as enthalpy of fusion. Are you able to understand my point? Okay, so or else in particular it is called as enthalpy of vaporization. Okay, if solid state getting converted into liquid state, or if liquid state gets converted into solid state, this is called as enthalpy of fusion. Enthalpy of fusion. Okay, yes, water has very high enthalpy of fusion. Okay, if liquid water freezes to ice, okay, large amount of energy is it released or absorbed? A large amount of energy is released. Large amount of energy is released. If okay, ice melts, large amount of energy is absorbed. Okay, that is what I mean. Okay, enthalpy of fusion. Okay, if liquid water freezes, okay, to form what? Ice. Okay, this is called as enthalpy of fusion. Or else if ice melts to form what? Liquid water. This is also called as enthalpy of fusion. So in both the cases, enthalpy of fusion is very high. Okay, yes, look at the unusual properties of what water in the solid and in the liquid state. It has very high dipole moment, it has high thermal conductivity, okay, and water has very high enthalpy of fusion. Okay, if it goes from liquid to solid, large amount of energy is absorbed. Okay, if it goes from solid to liquid, large amount of heat energy is released. Large amount of heat energy will be released. Okay, that is what enthalpy of fusion. Okay, since it has high enthalpy of fusion, look here, since it has high enthalpy of fusion, it acts as a moderator. It acts as what? Okay, since it has high enthalpy of fusion, water acts as a moderator. Okay, moderator. Why it acts as a what do you mean by moderator? It produces cooling effect. It produces cooling effect. That is what I mean by moderator. Okay, what do you mean by cooling effect? Have you seen people applying nail polish remover? Okay, girls applying nail polish remover. You please apply that nail polish remover on the surface of your hand. Okay, surface of your hand. Okay, yes, after some time, okay, that nail polish remover will evaporate. Okay, and the surface of your skin where you applied that nail polish remover will become cold. Why it becomes cold? Because what is happening here? Yes, the nail polish remover contains some water molecule. That water molecule will absorb the heat from the skin. The water molecule will absorb the heat from the skin and it gets evaporated. It gets evaporated. Okay, when it gets evaporated, what will happen? The temperature on the skin will decrease. When the temperature on the skin decreases, it will produce a cooling effect on your skin, isn't it? It will produce a cooling effect on your skin. That is what it is called as. That is why I'm telling you that water acts as a moderator. It has a cooling effect. It has a cooling effect. Yes, since it has high enthalpy of fusion, when it goes from solid to liquid or from liquid to solid, it has high enthalpy of fusion. That is why it acts as a moderator. You can observe, even in winter season in Antarctic sea or something like that, the surface of the sea will freeze. The surface of the sea will freeze, but aquatic animals will survive beneath the sea, isn't it? The aquatic animals will survive beneath the sea. Why? Because even though the surface water has freezed, it has converted into solid state. That solid will act as insulator. It will act as a perfect insulator. It will not allow the heat to penetrate into the sea. That is why the aquatic animals will survive. The aquatic animals will survive. That is related to the enthalpy of fusion of water. Enthalpy of fusion of water is very high. Yes, any doubts? And also water has high dielectric constant. Water has high dielectric constant. What do you mean by dielectric constant? Now look here, if I dissolve sodium chloride in water, when it is dissolved in water, now water molecules should break the bond between sodium and chlorine. Water molecules should break the bond between sodium and chlorine. When water molecules break the bond between sodium and chlorine, energy is released. That energy is called as what? Enthalpy, hydration enthalpy. Hydration enthalpy. It is called as hydration enthalpy, or else it is also called as lattice enthalpy, anything you might call. So when sodium chloride is dissolved in water molecules should break the bond between sodium and chlorine so that it gets ionized to give Na plus and Cl minus. That is what I am telling. Water has high dielectric constant. Since water has dielectric constant, it has greater capacity to break this bond. As a result, sodium chloride will dissociate to give Na plus and Cl minus. That is why majority of the substances can be dissolved in water. Hence we say water is a universal solvent. That is why we say water is a universal solvent, isn't it? Since it has dielectric constant, now high dielectric constant, it has the ability to dissolve, okay, majority of the compounds. That is why we say water is a universal solvent. Okay, so these are all the different physical properties and unusual physical properties of water in the solid state and in the liquid state. Now let us talk about what? Okay, yeah, the structure of water in the vapor phase and in the solid state. Okay, so shall we talk about the structure? Yes. Let us talk about the structure of water, okay, in the solid state. In the solid state, yeah. Okay, so one will be talking about the structure, yes, in vapor phase, okay, yes, and then we'll talk about the structure in solid phase. Solid phase, are you able to understand? Okay, the structure in vapor phase and the structure in which phase? Solid phase. Okay, so in vapor phase, guys, okay, look here. Okay, yes, so if I consider a water molecule, yes, in vapor phase, this in the oxygen of this water molecule is sp3 hybridized. Oxygen is sp3 hybridized. Okay, what is the state of hybridization here? sp3 hybridized. Okay, since oxygen is sp3 hybridized, it gives rise to 4 hybrid orbitals like this. 4 hybrid orbitals. Okay, 2 hybrid orbitals carry lone pair of electrons and 2 hybrid orbitals carry bond pair of electrons. Okay, please understand this point. Okay, I am talking about the structure of water in which phase? Vapor phase. In vapor phase, oxygen undergoes sp3 hybridization, gives rise to 4 hybrid orbitals. 2 hybrid orbitals carry lone pair of electrons. 2 hybrid orbitals carry bond pair of electrons. The hybrid orbitals carrying bond pair of electrons will overlap with 1s orbital of hydrogen. 1s orbital of hydrogen. This will overlap with 1s orbital of hydrogen and it forms a water molecule, isn't it? Okay, it forms a water molecule. Okay, this is overlapping. The hybrid orbitals carrying bond pair of electrons is overlapping with 1s orbital of hydrogen and 1s orbital of hydrogen, and therefore it forms the water molecule. Now what about the bond? Now since it is sp3 hybridization, we are expecting it to be a tetrahedral shape, isn't it? We are expecting it to be a tetrahedral, but the shape is not tetrahedral here. We call it as bent shape, or else it is called as V shape. Bent shape or V shape. What do you mean by bent shape or V shape? Okay, look here. See, because of the presence of lone pair of electrons, okay, according to valency shell electron pair repulsion theory, there will be repulsion between lone pair, lone pair, bond pair, lone pair, bond pair, lone pair and lone pair. Because of repulsion, okay, the bond angle gets contracted. The bond angle gets contracted. What is the actual bond angle in tetrahedral structure? It is 109 degree 28 minutes, isn't it? The actual bond angle in tetrahedral structure is 109 degree 28 minutes. But here, because of the repulsion between lone pair and bond pair, the bond angle gets contracted. Okay, therefore the bond angle is less than the normal tetrahedral angle. Actual bond angle here, it is 104 degree. Okay, you have to remember this. What is the bond angle in water molecule? It is 104 degree. Got it? Any doubts? Okay, why it is less than the normal tetrahedral? Okay, the shape is not regular tetrahedral. What is the shape here? It is bent shape or V shape. Okay, so why it is bent shape or V shape? Because of the extensive repulsion between lone pair, bond pair, lone pair and bond pair. Since these two pair of electrons repel, the bond angle gets contracted, hence the actual bond angle is less than the normal tetrahedral angle. What is actual bond angle in water molecule? It is 104 degree. Okay, so if I write water molecule like this, it has two lone pair of electrons and the bond angle is 104 degree. Okay, yes, what is the bond length? Okay, the bond length, it is 96.7 picometer. Okay, the OH bond length is 96.7 picometer. 96.7 picometer. Okay, I hope it is clear. Okay, this is about the structure of water. Now, okay, in vapor phase, what is the structure? Bend shape. What is the bond angle? 104 degree. What is the bond length? 96.7 picometer. Okay, what about the structure in solid phase? That means if you try to condense these liquids in the, if you try to condense the water molecules in the vapor phase, if you try to condense, okay, all the water molecules will come closer and closer, isn't it? When you condense the water molecules in the vapor phase, all the, when you start condensing it, when you start condensing the water molecules in the gaseous state, okay, now all the water molecules will come closer and closer and closer, isn't it? Okay, when the water molecules come closer and closer, look here what is going to happen. Okay, see what is happening here. Yes, when the water molecules come closer and closer, just like this, okay, just like this, isn't it? Look here, when the water molecules come closer and closer, this starts, okay, to develop hydrogen bond between oxygen and hydrogen. Okay, between what? Oxygen and hydrogen. Between oxygen and hydrogen, like this. Okay, between oxygen and hydrogen, just like this. This starts to develop what type of bonding? When they come closer and closer, they start to develop hydrogen bond. Okay, yes, so like this, isn't it? Okay, just like this. They start to develop what type of bond? Hydrogen bond. Hydrogen bond. Are you able to follow this? Okay, yes. They start developing hydrogen bond. Okay, so since they develop hydrogen bond, okay, they start to come closer and closer. As a result, if you condense further and further, okay, liquid now gaseous state will get condensed to what? Solid state. That means it gets freezed. Okay, when it freezes, when water freezes, we call that water as what? Ice, isn't it? When water freezes, we call it as what? Ice. That means I am talking about the structure of ice. Look at the structure of ice. How is it looking like? How is it looking like? Is it not looking like a cage like structure? Yes, it is looking like a cage like structure. Okay, or else we call it as honeycomb like structure. Honeycomb like structure. Okay, what is the structure called as? This is called as cage like structure on honeycomb like structure. See, since, okay, observe here, observe one water molecule. Okay, observe one water molecule. In one water molecule, oxygen forms two hydrogen bonds with the other two hydrogens, and each hydrogen will form hydrogen bonds with the other oxygen. That means in one water molecule, okay, there will be 4 hydrogen bonds. Okay, 4 hydrogen bonds per one water molecule. Okay, and since there is a gap, see, we call it as void. This empty space, and this empty space, this is called as void. Okay, and in these voids, okay, now these voids will be filled with air. Okay, this is empty space, this is also empty space. This empty space are called as what? Voids. And in these voids there will be air. Air is filled in these voids. Since air gets filled in the voids, okay, what will happen? Ice will become less denser than water. Okay, ice is less denser than water because of its honeycomb like structure or cage like structure. That is why ice floats on water. Ice floats on water. So what is this structure called as? Honeycomb like structure or cage like structure. Remember, okay, ice is a good insulator. It's not a good conductor, it is an good insulator. It's an insulator. Okay, got it? So guys, this is all about the structure of water in vapor phase and in solid state. Okay, in my next video I'll be talking about the chemical properties. Now in the next we will go ahead with the MCQs related to, okay, the physical properties of water, the structure of water in the vapor phase and the structure of water in the solid phase. Okay, yes. Friends, now we will solve MCQs upon water. Okay, I have left out one MCQ from hydrides. We will solve this and we'll go to the next MCQ. Okay, yes. What is this question? Non-stoichiometric hydrides are produced by. Non-stoichiometric means metallic hydrides. Okay, means what? Metallic hydrides. And when do you get metallic hydrides? When will you get metallic hydrides? When hydrogen combines with, okay, D block elements, okay, from group 3 to group 5, from group 3 to group 5. So here, okay, we have manganese. Manganese is, okay, yes, it's a D block element, correct. Nitrogen is a P block element. Carbon is also, okay, carbon is also what? Okay, P block element. Nitrogen and fluorine both are P block. Carbon and nickel, okay, non-stoichiometric hydrides are produced by carbon and nickel. Nickel is D block element. Okay, so manganese and lithium. Manganese is D block, lithium is, okay, S block. Yes, palladium is what? Palladium is D block. Vanadium is also D block. Okay, so D block elements will produce metallic hydrides. Therefore the correct answer is A. Correct answer is A. So can B be the correct answer? No. This will form metallic hydride, but this will form ionic hydride. Okay, here both of them, nitrogen and fluorine, will form what type of hydride? Covalent hydride. Carbon will form covalent hydride. Nickel is going to form, okay, what? Metallic hydride. But both the in option A, both of them will form, okay, metallic hydrides, because both of them are from D block. Okay, yes. Next question. So correct answer is A. Yeah. Next question. The density of water, okay, is less in its solid state because, okay, what is the reason? Okay, what is the reason? Yes, we have discussed about the structure of water in solid state. Look here, in solid state, yes, hydrogen, okay, that means water molecule gets condensed. Okay, water molecule gets condensed to form hydrogen bond, isn't it? Like this. Okay, water molecule gets condensed to form hydrogen bond. Okay, and in between the molecules there will be voids. Okay, and in these voids air is filled. Since air is filled in this empty space, okay, it becomes less denser and hence ice will float on water. Is that correct? Yes. So what is the correct answer? The density of water is less in its solid state because in solid state water molecules are, okay, arranged in a highly ordered open cage like structure. Yes, they are highly ordered, okay, in open cage like structure. Open cage like structure. Okay, and in option B more extensive hydrogen bonding is present. Okay, that is fine, but it is not the correct reason. The water molecules are closest in solid state, that is also fine, but it is not the correct reasons. Water is rigid crystalline, that is correct, but it is not the correct reason. What is the correct reason? In solid state all the water molecules will be associated in a highly ordered way. Okay, and in between water molecules there will be empty space, and that empty space will be filled with air. Since air is filled, okay, now water in the solid state will become less denser. So the correct option is option A. Option A. Next question. Okay, which of the following statements, okay, given below are true for the structure of water molecule? Which of the following statements, okay, yes, is oxygen undergoes sp3 hybridization? That is true. We have discussed the structure of water molecule. Oxygen undergoes sp3 hybridization, correct. Okay, due to presence of two lone pair of electrons, okay, on oxygen, the HOH bond angle is 118.4 degree. No, it is not correct. Look here, I have discussed because of valency shell electron pair repulsion theory, because of the presence of two lone pair of electrons, okay, because of the presence of two lone pair of electrons, the bond angle will be less than the normal tetrahedral angle. What is the normal tetrahedral angle? It is 109.5 degree. Because of the repulsion between lone pair bond pair, because of the repulsion between lone pair, the bond angle will be less than the normal tetrahedral angle. What is the bond angle in water? It is 105 degree. It is not 18.4 degree. This statement is wrong. Okay, first statement is correct. Next, due to angular geometry, the net dipole moment of water is not zero. Yes. Okay. What about the dipole moment of water? Yes, here in this bond the dipole moment is towards oxygen. Okay, the dipole moment is towards oxygen. The net dipole moment is in this direction. Okay, yes, so this is also correct. Due to the angular geometry, the net dipole moment of water is not zero and it has a definite dipole moment. What is the dipole moment here? It is 1.84 dBi. Okay, yes, I have told you that. Okay, water has highest dipole moment. Water has highest dipole moment, hence it is highly polar. That is why it is called as a polar solvent. So I can say first option is correct, third option is correct. Can we have look into the options here? Yes, it is option A, where 1 and 3 are correct, isn't it? Yes. Next question. Okay, the maximum number of hydrogen bonds formed by a water molecule in ice is, okay, look here, yes, oxygen. Okay, so this is, if this is a water molecule, okay, maximum number of hydrogen bonds. Okay, yes, so oxygen will form hydrogen bonds with two hydrogens. Okay, and each hydrogen will form, okay, hydrogen bond with the next oxygen. So total number of hydrogen bonds here is, total number of hydrogen bonds, observe this one molecule of water. Observe one molecule of water. Oxygen will form two hydrogen bonds with hydrogen and each hydrogen will form hydrogen bond with oxygen. Therefore, the total number of hydrogen bonds are how much? It is 4, isn't it? So, the total number of hydrogen bonds per molecule of water is equal to how much? 4, correct? Okay, yes. Next. Okay students, that's all with the MCQs related to water molecule. In the next video, we will talk about the chemical properties of water and the different methods of softening of hard water. Okay, thank you.